So welcome back, and we're going to dive straight back into the questions we were looking at last time. You'll remember that there were 3 that we asked you to try. If you haven't tried them yet, please try them before watching us do them. All right? You're not going to get better at maths by watching us do maths. Excuse me. Right. So here we've got a situation, right? We do know that these 2 angles are going to add to 180 degrees, but that's not going to help us, right? Because we don't know what either of them is. But we do here have these 2 angles that are vertically opposite. What do we know about vertically opposite angles? Well, we know that they are equal. So we can make an equation, 6f equals 4f plus 20 degrees. Don't forget, we must have a reason, and our reason is vert op angles. Okay, right. So now we've got a little equation to solve. Let's subtract 4f from both sides. 6f minus 4f is 2f. 4f minus 4f is nothing, but we've still got the 20 degrees here. Now we're going to divide both sides by 2, and so we get that f is 10 degrees. Right. If f is 10 degrees, this angle over here is actually 60 degrees. Okay, now G is next door, so G will just be the supplement of 60 degrees. It will be the 180 minus 60. G will be 120 degrees, and the reason we know that is angles on straight line. Okay. Right, this one over here, quite a lot going on, but we've got 2h and 2h, and that shouldn't surprise us. Those must be equal, right? Our challenge is to find out what size h is. All right, notice that writing down 2h equals 2h won't help us because h could be anything. But what do we know about these 2 angles? This one here and this one here. That's right, they're on a straight line. What do we know about angles on a straight line? We know that they add to 180 degrees. All right, so let's write down our equation. Don't forget to give a reason. 3h plus 2h. 3h plus 2h is 180 degrees. So 5h is 180 degrees. So h is, let's divide both sides by 5, h is 36 degrees. Don't forget to give the reason. The reason here, angles on straight line. Right, the last one is very straightforward. I is a vertically opposite angle, so I will just be 90 degrees. I equals 90 degrees, vert op angles. Okay, right, on to page 50. So this now is an exercise to practice everything we've done. Okay, so we're going to ask you to pause the video, and we're going to ask you to try this consolidation task, and then we will go over it together, and then we'll move on to something new. Okay, the first one asks us to estimate the sizes of these angles. All right, and I don't know that this time I didn't write down the exact size of the one on the page. All right, so I hope I'm going to be okay here. This first one I would say is about 40 degrees, and it is definitely acute. This next one looks to me to be very much like 90 degrees, so it is a right angle. Right, this one here, I'm thinking maybe about 135 degrees. And it's an obtuse angle. This one over here, I'm actually looking at this little piece inside here and thinking that that looks maybe like about 30 degrees. And if that's 30 degrees, then this must be 360 minus 30. This must be about 330 degrees. I'm estimating, okay? And this one here is a reflex angle. Right, question 2. Give the complement of 78. That means what must we add to 78 to get up to 90 degrees? And the answer is 12 degrees. Give the supplement of 121 degrees. What must we add to 121 to get up to 180 degrees? And it will be 9 degrees to get to 130, and then another 50 degrees. So 59 degrees. Right, now we've got 4 questions where we asked to find the size of x. All right, we can't do this question at all, so we're missing information here. I am going to just add something in here. I'm going to write here that this is 340 degrees. Okay, now this question is possible, and we hope that you can see that our equation would be x plus 340 is 360 degrees. So what's x? X is 20 degrees. The only thing we haven't done is written down our reason. Don't forget our reason. This is angles round a point. Okay, this one over here, again, we've got a whole lot of angles round a point. We've got 108 degrees. We've got plus 54 degrees, plus 90 degrees, plus x, and that must all come to 360 degrees. Reason, angles round a point. Right, let's collect the like terms here. We've got 3 numbers. 108 plus 54 is 162. 162 plus 90 is 252. 252 degrees plus x equals 360 degrees. Let's subtract 252 from both sides. All right, and we get 108 degrees. Right, number 3. Well, we can easily see that x is just going to be 63 degrees. Our reason, vert, op, angles. Okay, now we know that 63 plus y is 180 degrees. These are angles on a straight line. So let's subtract 63 from both sides, and we get that y is 117 degrees. Okay, the last one, okay, this just requires a little bit of thought, because what I hope we can see here is that we've actually got a straight line here and a straight line here. All right, so in fact, these two angles, y and 29 added together, y plus 29 must equal 125 degrees. All right, and the reason is vert, op, angles. Okay, now to get y, let's just subtract 29 from both sides. Okay, and we get 96 degrees. Okay, all right, that brings us to the end of this first little piece. The next piece we're going to look at is parallel lines. Okay, and so just a few things. Remember, parallel lines are lines that are exactly the same distance apart. We use this symbol, two little vertical lines, as an abbreviation for parallel. All right, so, and we put arrows on lines to indicate that they're parallel. So notice this one's got 2 arrows on. Those 2 lines are parallel. Line AB is parallel to CD. They're exactly the same distance apart. They will never meet. All right. We can also have curved lines that are parallel, so the 2 railway tracks are parallel. But in our geometry, we're only going to worry about straight lines that are parallel. Notice that this line has got 1 arrow on, so has this line. So line BC is parallel to line AD. Another little thing that we do is we put little marks on lines to show that they are equal in length. So that there, it's not an arrow, it's just a little dash. Those two lines have the same length. EF is equal to EH. And these two have got a different mark on. They've got two little lines. That means that those two lines are equal. All right. Now, we've now got a pair of parallel lines. So we've got a parallel line here and another one here. Okay. And we've got a total of, then we've got a line that's cutting them. We actually call that line a transversal. Okay. And that green transversal cuts the two parallel lines, and there's actually 8 angles that get formed. We want you to try and estimate the size of the 8 angles that are formed in this particular diagram. So we're going to ask you to pause the video and try and fill in the table just an estimate of the size of the eight angles. Okay, so angle number 1, I'm going for, I'm not 100% sure, but I'm going for maybe about 130 degrees, maybe 130 degrees. Now, it looks to me to be the same sort of size as angle number 5. So angle number 5, I'm actually also going to go with 130 degrees. Notice that these two, 1 and 3, are vertically opposite. So if I'm going for 130, then I think 3 must also be the same size. Maybe I went with 131, but then it would be 131. And likewise, number 5 and number 7 are actually going to be the same size. Right. So I'm not sure if these numbers are right, but all 4 of those look to be the same size. Now, if I've gone with 130 here, I can't go with 60 here. Right? And the reason I can't go with 60 is that these ones are next to each other on a straight line. So if I'm saying this is 130, then I'm basically saying that number 2 must be about 50 degrees. All right, or 50 degrees. Okay, and likewise, if that's 50, then these are vertically opposite. This one must be 50. This one must be 50. All right, because it's next door to 130. And this one must be 50 because it's opposite a 50. All right. I'm hoping that when you fill this in, it doesn't really matter exactly what number you got here, but that you got the same number for 1, 3, 5, and 7. And then you got a different number, but the same number for each 2, 4, 6, and 8. Because that is in fact exactly what happens with parallel lines. When we have parallel lines, all right, we get a whole lot of angles that get formed. Okay, and I've actually got a set of parallel lines over here. All right, so we've got these 2 lines, the purple line and the green line. Okay, and if they're parallel, then we've got all these 8 angles that get formed. But we have angles that are called corresponding angles. All right, and corresponding basically means that they're in the same position. So there and there, or there and there, or there and there, or there and there. All right, you'll see we've numbered them. Number 1 and number 5 are corresponding. Number 4 and number 8 are corresponding. Number 2 and number 6 are corresponding. And number 3 and number 7 are corresponding. And in each case, they will be equal if the lines are parallel. Notice if the lines aren't parallel, these corresponding angles will not be equal. Okay, they are only equal when the lines are parallel. Okay, right. Then we've got 2 pairs of angles called alternate angles. Alternate means to swap. They are on opposite sides of the transversal. So number 4 and number 6 are alternate angles. If the lines are parallel, they will be equal. All right. Likewise, number 3, I wanted to do that a different color. number 3, and number 5 are alternate angles. Okay, and then the last type of angles that we need to learn are what are called co-interior angles. Co means together, interior means inside. So co-interior angles are like this green one and this blue one. And you can see they don't look equal. In fact, they aren't equal. All right? So that green one and that blue one are co-interior. Also, this yellow one is together inside with this pink one. So the yellow and the pink, number 3 and number 6, are co-interior together inside, and number 4 and number 5, the blue and the green. And if we have parallel lines, then those angles are supplementary. They add up to 180 degrees. Okay, and then, so we've basically got a really big idea here, is that if we've got parallel lines, the corresponding angles are equal, but this arrow has got a head on both sides, so it can go the other way. If we've got corresponding angles equal, then we know the lines must be parallel. If the lines are parallel, alternate angles are equal, and if alternate angles are equal, the lines are parallel. If the lines are parallel, co-interior angles are supplementary, and the other way around. If the co-interior angles are supplementary, we've got parallel lines. Okay, we can also write it like this, okay? If parallel lines are parallel if and only if the corresponding angles are equal. So the lines are parallel if the corresponding angles are equal, and they're parallel only if the corresponding angles are equal. So both things happen together. Right, we're going to pause the video here and we're going to just show you a little sketch just to help with your understanding of this. Okay, so let's just take a look here. We've got these parallel lines, all right, and notice we can kind of move the lines, and the lines are both staying parallel, all right. We can move this line up and down. We can also move this kind of transversal, right. Notice we've got these little arrows on to say that they're parallel. Now we're going to move, and I'm going to show you the corresponding position, all right. So when I drag this red slider, that red angle moves into its corresponding position. And notice it's exactly the same size. It fits in there. Let's do the green one. It's going to slide down into its corresponding position. It's going to slide down to here. Let's have a look. There it is. Those two angles are corresponding. The pink one, corresponding. Okay, and lastly the blue one, corresponding. Okay, I'm going to just change up the diagram slightly. We're going to move that like right across to there, that across to there, all right? And let's move the red one. Think about where its corresponding position is. That's right, it's in the same place, just lower down, okay, on the other parallel line. The green one, think about where it's going to go. That's right, it's down there. The pink one, that's right, it's down there. And the blue one, that's right, it's down there. All right, those are corresponding angles. Okay, now we're going to show you alternate angles. All right, these two angles here we can see add up to 180 degrees. Notice that if we move that blue angle, and notice its size is not changing, but we move it around, it goes into its alternate position. And what you'll notice is that it's exactly the same size. The same with the pink one. The pink one's alternate. Alternate means to swap. So it swaps onto the other side of the transversal. The pink one stays exactly the same size. Right, now remember that a pink plus a blue add to 180 degrees. So in fact, when we move the pink one round to there, these two are called co-interior angles, and they add up to 180 degrees as long as the lines are parallel. Okay, if I move the blue one round into its alternate position, you'll see those are alternate positions, the two blue positions, and notice that they are on a parallel, they're on a straight line. A pink plus a blue is 180 degrees. If I move the pink one into its alternate position, its alternate position's there, it'll be exactly the same. All right, so alternate angles are equal when the lines are parallel, but what we've got here is we've got co-interior angles, and co-interior angles together inside, all right, are supplementary. They're not equal. They are supplementary. All right. So what we want you to do before the next lesson, we want you to learn those names. We want you to learn those positions. Just to make it clear, if we go back into our workbook here, all right, we want you to learn all this information at the top of the page. All right, we'll test you on it next time, okay, and we will practice using it. All right, have a great day, everyone.